The strange truth is that Earth has already survived things far worse than humanity. When people imagine a nuclear war between Israel and Iraq, the assumption is usually the same. The planet would be destroyed, oceans boiling, continents burning, life erased. But when scientists actually study the Earth system, its atmosphere, oceans, microbes, and ecosystems, they reach a very different conclusion. The planet itself would almost certainly survive. The real question is not whether Earth survives. The real question is whether modern human civilization would. Earth is resilient in ways that are difficult to grasp because most of its recovery processes happen slowly and quietly through chemistry, climate feedback loops, and biological adaptation. The idea of nuclear winter is one of the most misunderstood environmental effects. The phrase nuclear winter first appeared in scientific research during the Cold War, when climate scientists began studying what happens after large nuclear detonations ignite cities and industrial areas. The concern wasn't just radiation, it was smoke. When urban areas burn at extreme temperatures, often above 800 degrees Celsius, they release enormous plumes of black carbon soot. These soot particles rise into the upper atmosphere, especially the stratosphere, where rainfall cannot easily wash them away. This process forms what scientists call nuclear winter. Instead of warming the planet like greenhouse gases do, black carbon blocks incoming sunlight. Computer climate models show that even a limited nuclear exchange could inject millions of tons of soot into the upper atmosphere. That soot could reduce global sunlight by 10 to 30% for several years. Less sunlight means cooler temperatures, crops fail, growing seasons shrink, ocean ecosystems shift because less sunlight reaches plankton near the surface. The surprising part is that the cooling would not be uniform. Some regions might experience severe agricultural collapse, while others remain relatively stable. The atmosphere behaves like a giant mixing machine after major explosions. When nuclear weapons detonate, they produce towering mushroom clouds that can rise 10 to 15 kilometers into the sky. These clouds carry dust, ash, and combustion byproducts upward where atmospheric circulation spreads them across continents. But the Earth's atmosphere is not static. Winds in the stratosphere slowly move particles around the planet while chemical reactions gradually break them down. For example, black carbon particles eventually settle or oxidize. Radioactive isotopes decay according to predictable half-lives. Even large atmospheric disruptions begin to dissipate over time. After the Hiroshima atomic bombing and Nagasaki atomic bombing in 1945, radiation levels in those cities declined significantly within decades. Today, both locations are densely populated again. That doesn't mean nuclear war is survivable for society. It means Earth's physical systems slowly dilute and transform the damage. Radiation behaves differently in ecosystems than most people assume. One of the most fascinating things scientists have observed comes from the region around the Chernobyl exclusion zone. After the Chernobyl nuclear disaster in 1986, large areas became unsafe for human habitation. But wildlife began returning surprisingly quickly. Wolves, wild horses, birds, and forests gradually repopulated the region. Radiation is still present, and it absolutely affects organisms at the cellular level, but ecosystems adapt in unexpected ways. Some fungi even appear to use radiation as an energy source through a pigment called melanin, a process sometimes described as radiotrophic growth. Microbes, plants, and insects evolve faster than humans, and their ability to adapt is part of why life on Earth has survived mass extinctions before. Earth has already endured catastrophic events far beyond nuclear war. About 66 million years ago, the Cretaceous Paleogene extinction event wiped out roughly 3/4 of all species on Earth. A massive asteroid impact threw enormous amounts of dust and sulfur into the atmosphere, blocking sunlight and cooling the planet. In many ways, the climate shock from that impact resembled what scientists expect from extreme nuclear winter scenarios. But life recovered. Forests regrew, oceans stabilized, mammals diversified. Over millions of years, ecosystems reorganized into entirely new forms. Earth's history shows a pattern. Life collapses locally or regionally, but the biosphere eventually rebuilds. The real danger of nuclear war is not planetary destruction, but ecological disruption. If a nuclear exchange occurred between regional powers like Israel and Iraq, the direct blast damage would be geographically limited compared with a full global nuclear war. However, fires in cities and industrial zones could still inject soot into the atmosphere. Climate simulations suggest even a relatively small nuclear conflict could cool global temperatures by 1 or 2 degrees Celsius for several years. That may not sound dramatic, but agriculture is extremely sensitive to temperature and sunlight changes. Corn, wheat, and rice all require stable growing conditions. Even small climate shifts could cause widespread crop failures across multiple continents. Oceans would also react. Less sunlight means less photosynthesis for phytoplankton, which form the base of marine food webs. A drop in plankton productivity can ripple upward to fish populations and eventually human food supplies. So while forests and microbes may recover, global civilization could struggle. The planet itself is more durable than civilization. This is the strange perspective that emerges when scientists study Earth as a system, rather than focusing only on human consequences. The lithosphere, the rocky crust of the planet, would remain unchanged. The oceans would still circulate. Atmospheric chemistry would eventually rebalance. But modern civilization depends on incredibly fragile networks. Electricity grids, global shipping, fertilizer production, and international agriculture all operate on tight margins. A major nuclear conflict could disrupt those systems for years. In other words, the planet would continue. Humans might not manage the transition very well. The deeper lesson is that Earth's resilience should not be confused with safety. Earth has survived asteroid impacts, supervolcano eruptions, and massive climate shifts. From a planetary perspective, nuclear war is another disturbance in a very long geological timeline. But for a species that relies on global stability, even temporary environmental shocks can be devastating. The same atmospheric systems that protect life by circulating air and water can also spread smoke and radiation across continents. The same oceans that regulate climate can also amplify disruptions to marine ecosystems. Earth's resilience is real, but it operates on timescales much longer than human societies. The strange truth is that our planet is both incredibly tough and surprisingly delicate at the same time. Geological systems can absorb shocks that would collapse entire civilizations, yet the biosphere constantly evolves to adapt to whatever happens next. And that is what makes studying Earth so fascinating. Beneath every headline about conflict or disaster lies a deeper story about how this planet actually works. If you enjoy exploring the hidden science and strange processes that shape our world, subscribe to Strange and Curious Planet and share this video with someone who loves uncovering the mysteries of Earth. There are countless phenomena happening around us every day, and the more we understand them, the more extraordinary our planet becomes.